Should get started because our community meeting has always been, because of the time we have here, it's late time in Asia, so a lot of people, well, I wouldn't say a lot, but most people watch it on the YouTube for the recording later. So let's get started, and then people can watch it later. So we have a very tight agenda today, and and most things we're going to talk about are related to the WasmEdge 0.14, which was just released in the last month. So this release has come along for we have talked about it for many months, and it's finally get released. So now it's time to properly introduce some of the more important features of this release. So we're gonna so we have 4 talks. We're gonna start with Hydai to talk about the overall features, and then we're gonna switch to Fenda to talk about the JIT feature, which is a thing a lot of people ask about, because in the past we only have the AOT and the interpreter. So AOT is very fast, but it requires extra work. The interpreter, on the other hand, is quite slow. So the JIT fills a hole in between. So allows people to run their Wasm application without any the AOT steps, but it's still at reasonable speed. Then we're gonna have Zalim to talk about how Kotlin uses WasmGC, which is one of the most important features in 0.14, and it enables us the ability to support new languages like Kotlin. So I think that's be a great news for a lot of people who come from the Android Java background. So, and then last, we're gonna switch back to Fenda to talk about running our large language model plugin on Windows. So in the past on Windows, we have required WSL, Windows as subsystem for Linux, but now we have a full Windows native solution, both on WasmEdge and also on the large language model plugin. So without further ado, let's Hydai, please start.
I need a permission to share my screen. So, Vivian, please.
Yeah, you should be the co-host.
You can share your screen right now.
Okay. Can you guys see my screen?
Yes.
Okay, great. So today I'm going to talk about the highlight of our 14.0 release. And here we are. So first thing is that we support more powerful LLM plugin, which is the llama.cpp, and we currently will maintain 2 LTS updates. One is for the 13.5, and the other is for the 14.0. So once the llama.cpp has anything update, we will sync up and then renew our assay. So with this, we can make sure that our LLM plugin always up to date and fully synced with the llama.cpp. Yeah, so this is the first thing. And in this version, we also support 3 very important Wasm proposal. The one is the type function reference proposal, and the other one is the exception handling proposal. And currently, we only have the interpreter support in this proposal. And for the JIT and the LT support is still underway. We are developing it, and maybe it will be shipped in our next major release. Yeah. And the other one is that we support the WasmGC proposal. Most of it are implemented in the interpreter mode, and also the JIT and the health time compilation support is still underway. Also, just Michael mentioned that we have the LLVM JIT execution in this release. So this is still the experimental feature. So you may encounter some issue if you are trying to run a very complex application, and the behavior may be correct, may not be correct. If you encounter that, please raise an issue so we can we can figure out, because we only run the test suite from the Wasm and WasI proposal, and we only run the application that we create for the examples. So I would say it's still experimental. So please give a try, and we are happy to hear any feedback. And the other one is that in this release, we already have the loader phase component model support. So now we can at least parse the component model file and identify that. However, for the instantiation, the execution will be shipped in our 14.1 release. It will be our next release to have more functionalities and features of the component model. And the last one is that we make the GGML plugin support on the Windows platform. So let's see some changes. If you are using our library, so one very important issue is that because we support lots of new proposals, so some of the data structure is changed. So you may need to update your related header or the shared library to our 0.1.0 version. And also, if you are using the plugin, you need to recompile your plugin with our 14.0 library. The reason is that to reduce some to simplify the plugin workflow, we do lots of changes in the data structure. So you will need to recompile the plugin, which means that you cannot just pick up a 13.5 plugin and put it into the 14.0. It's not compatible. So this is the thing that if you are using our library or you are using our plugin, please make sure you have updated your code base. And we do have several new data structures, such as the new value type. In the previous release is the enumation, but because we have to record more metadata and more detail inside, so it become a structure now. And we also introduce the bytes data structure, and we're refactoring the code. So there's lots of detail changes. Please check our change log to see the detail things. So does the exception handling proposal. We add several new structures and the help functions to interact with that. Also, in this version, we support experimental function inside our libWasmEdge. So you can now use the loader serialize to serialize our the SD module into bytes. Yeah, so this is one of the new features here. And also, previously we encountered that several people say that they don't know the plugin is loaded into WasmEdge and the detail of the plugin. So in this version, when you call the WasmEdge -- version, it will not only show the WasmEdge version, it will also show the plugin it found and the plugin name and the plugin version here. Yeah, so you can find the whole details. If you have multiple plugin, then there will be multiple line. Each line will be one plugin it found. Yeah. And the lesson of our 14.0 is that we thanks all of these contributors because of these people, so we can make the 14.0. And the last slide is I just want to mention that in our next release, we will have the following new features. So we will have the Intel Neural Split Framework, and we will have the Stable Diffusion CPP. So now you can use different framework to run your AI LLM model, or you can use our Stable Diffusion plugin to use to generate images from the text prompt. Also, we will ship the Relax SIMD proposal, and the most important thing is that we will have more functionality of the component model support, including the linear index space, and lots of different definitions and sections will be implemented. And we will have two demo. One demo is we will use the WasmEdge HTTP, so you can just pass a URL string and to do some query on it. And we will also have another example is using the Wasm pool. Yeah, so there will be our new features in the next release. And we, according to our timeline, this new version should be released at the end of this month. So stay tuned for it. Yeah, that's all of my slide. Thank you.
All right, thank you, Hydai. Yeah, that's I find that's a lot of work, So yeah, that's but also a lot of new features. And one thing I do want to note is that if you have a Wasm application that was written that working before on 0.13, it's gonna still work on 0.14, right? So it's so at the Wasm application level, it's compatible across those two releases. It's SDK APIs, and if you are developing plugins, and if you are developing applications, that's interact with WasmEdge runtime itself, that you would have, encounter a lot of those API changes, like Hydai said, you need to recompile things. So anyway, yeah. So let's keep all the questions at the end of the talk. So right now let's move to the next one about. So I want to ask one of the co-engineers of Wasm. Yeah, so Mr. Fendache, and he's gonna talk about the JIT support in WasmEdge, please.
Okay, let me share my screen.
Okay, I see it.
I'm going to demo the feature for this WasmEdge version, that is JIT mode. And first, you have to use the newest WasmEdge version. And we will have a new option called Enable JIT. And you will compile the Wasm file on the fly and run it. And I prepared a demo Wasm file called FLAC. And this file is a tool compiled from original FLAC tool, which is an utility tool to encode some audio file into a compressed version. It has a test flag can test any FLAC file to check that the file is it's okay or not. And now I use WasmEdge to run the FLAC version of it and try to test this file without JIT flag. By calling this WasmEdge will enter the interpreter mode and to run this FLAC file. And as you can see, it's very slow. Before this version, we should use an AOT compiler to compile this file into a compiled version like this. And I can run the compiled version of FLAC and get the fed normal speed like this. And now for the newest version of WasmEdge, you can use Enable JIT, and now it will compile the WasmEdge file on the fly. And after it compiles, it will run the test command, and you can see that it's very fast now. I think that's all. You can try this Enable JIT flag, but it's still in experimental, so it may be not that fast as you may think. Yeah, that's all.
So yeah, I have a quick question. So there is still a step. When we do enable JIT, it's still a step to do the compile. But this is the JIT compile, not the AOT compile. So it's faster. Is that right? Yeah.
Yeah, because it's an AOT version optimized a lot to generate the best binary as it can, but the JIT version is just optimized a little bit for a little bit faster runtime only. So in total, running a AOT compilation plus an invocation will be a bit slower than run the JIT version.
Okay, so the startup time of the JIT is a lot faster than start time for the AOT. Is that correct? Okay.
So if I run the compilation and plus no more invocation, well, a little bit slower. The compile time is already bigger than JIT version.
Okay.
And this one plus this will longer than JIT version. Yeah.
Okay. All right. Yeah.
That's all.
That's great. Thank you.
Any questions?
Yeah, we can ask additional questions at the end, so people have some time to think what they want to ask, right? Yeah.
Okay.
All right. Thank you. Yeah. So in the next stop, we can have Zalim to talk about, a feature we talked about many times. I think more than a year ago, we first met at WasmIO to talk about, GC support, and that was the first, one of the first compelling use case we see for Wasm GC is to enabling new languages, and it did took us a very long time to get here, but I think we're finally here. So please, let's talk about Kotlin support.
Thank you for inviting me. Do you see my screen?
Yes.
Okay, nice. Yeah. First of all, I want to congratulate the team, WasmEdge team, with 0.14 release. You did a great job, and since this version, Kotlin applications could be run inside WasmEdge when they compile to WebAssembly, of course. Nice job. Thank you for support GC proposal. So yeah, I'm here to talk about Kotlin and Kotlin WebAssembly. I'll do my best to make the talk short and informative. And before start, I'd like to clarify a bit and set expectations. Today, I will not speak about how exactly we use GC proposal. Instead, I want to make a short introduction to Kotlin Wasm and show some examples, of course, with WasmEdge as well. And I think it's more beneficial for users, for your users, for our users. And in case if someone wants to know more about some internal things, there was a talk from WasmIO 2023 where we cover a bit some internal details, how we use Wasm GC. I drop the link a bit later. And after all, if you want to hear more about Kotlin Wasm, about current state, what we are doing now, what we're able to do, you can check out my recent talk at KotlinConf. It's more wide talk than today one. And don't worry about links. All links mentioned during the talk, I will repeat at the end, and of course share a link to the slides. So let's move. Probably JetBrains is most known for its keys for different languages like Java, C#, Rust, and so on, and many other languages. Also, we have team tools for issue tracking, CI. And in other words, why I speak about JetBrains is we are making tools for developers, and not external developers, but for ourselves, including for ourselves. And we are really care about development experience, because the things we doing, we actually using every day by ourselves. Kotlin is also created by JetBrains, mostly derived by internal needs originally, but later it become something bigger. Kotlin is modern programming language. It has multiple targets, JVM, which is popular on server side and Android development, many native targets like iOS, Linux, and so on, JavaScript, and of course WebAssembly. With this multi-platform capability, you can share as much as you want between all these targets. But if you need for some reason to write some platform-specific code, you of course can do that as well, and you have some special interoperability things for specific platform. Kotlin probably the most known for its null safety, which turned the $1 billion mistake to compile time check. It's statically typed language with automatic memory management, basically GC, and it managed to be concise and expressive. I personally love how Kotlin is programmatic in language design and tooling design, but Kotlin a bit more than just language. It's a big ecosystem with a big and friendly community, with bunch of tools around Kotlin, IDEs, build tools, and many other things. Many libraries around, both built by JetBrains and by community. Kotlin Wasm aims to combine these two powerful technologies and allow developers to write efficient and portable code and build a wide range applications from high-performance web applications to serverless functions. We're working on Kotlin Wasm to chain with following goals in mind. First of all, it's compilation time. We want to have fast compilation because we believe having under the second time round trip time is very important, and to achieve that, we trying to control how compiler pipeline. We don't use any external code generator things. We generate binaries directly, and right now we're working on making it incremental. We have separate development and release builds. So in development builds, we don't do much optimizations. It's more optimized for a round trip. And in release builds, we are applying optimizations, including external tools like Binarion, to get better performance at runtime and to get better result in terms of size. We want to have a great integration with hosts, for example, to avoid leaks for cross-model links between different Wasm models, or with links across boundary with host. We want to provide convenient and fast interop with host. For example, we provide out-of-the-box declarations for many browser APIs, so you can easily work with both APIs or with DOM API. Of course, we are going to provide the same level of experience for outside of browser usages for WYSI by pre-generating some declarations, or providing tools to generate Kotlin type definitions for typing based on WIT files. And we want to have small binaries. For this example, size of final binary is 4 kilobytes. To run binaries produced by Kotlin Wasm to chain WebAssembly virtual machine must support garbage collection proposal and exception handling proposal. However, exception handling proposal is not strictly required. It's like it's better to say like we have special experimental mode when you can produce binaries without. Depends on exception handling, but it's more for experimenting with virtual machines, which doesn't support exception handling yet. Anyway, fortunately, WasmEdge since 0.14 support both proposals, so you can easily run Kotlin applications with this VM. For WebAssembly, we introduced two new Kotlin targets, WasmJS and WasmWYSI. With JS target, we assume that the environment has JavaScript support. It's mainly for use cases inside the browser. It works well inside Chromium-based browsers. It works in Firefox as well. Basically, it's done in Safari, but off by default yet. I hope it will be on by default soon as well. It's for browser applications, we're also able to debug Kotlin applications run there via browser dev tools or IDE. We are continuing improving it, and for outside of browser cases, also we want to have the same level of debug capabilities, and going to invest there next few months by providing bug capabilities for standalone VMs as well. Also, for browser use case, we also working on library for developing UI of applications. It's called Compose Multi-Platform. It allows you to share UI across all Kotlin platforms. specifically on Android, iOS, desktop, and web, of course. Yeah, you can see picture here. It's Kotlin Conf app, and it's 100% written in Kotlin, and most of UI is shared across all platforms, and it works similar on all platforms. Speaking about WYSI, we understand how WYSI support is important for outside of browser usages, and we introduced a dedicated target for that. Right now, it's based on WYSI Preview 1, but we are working on supporting component model and WYSI 0.2. Yeah, that's demo time. So I'm going to use our examples collection hosted on GitHub, and want to show a couple of demos. Here we have a bunch of demo applications. It's one GitHub repository, but basically examples independent from each other. You can just open a directory of example. This README file which describe what kind of application it is, and instructions how to build, how to run that. Here we have a bunch of browser-based applications, some Node.js example, WYSI example. Yeah, for browser examples, we also have online demo. You can just open online demo and play how it works in life. Specifically, in this example, JetSnake originally was written for Android, and looks like this. We just easily port it to our web target, and it looks like, yeah, basically it works. Yeah, you can see here other examples, and can play with them, check out of them. Yeah, example what showed before, Kotlin Conf app. Here how it works inside browser. Here we have speakers and something like that. Yeah, it can work desktop application. Actually, you can even install it, and yeah, you can run it. It will work. It will look like desktop application. It works offline. It can show notifications. Quite powerful. What's next? Let me check. Yeah, I want to switch to my code editor Fleet and show example with WYSI. It's super simple example. We just print here some constant strings and print some timestamps, real timestamp, monotonic timestamp. At the end, to get timestamps, we use imported function from WYSI Preview 1 called timeGet. But it's not convenient to use directly this API because you need to work with pointers and so on. So we introduced here some helpers. And to hood, these helpers actually both use another one by providing right time ID. What we do in WYSI getTime, we use memory allocator to allocate a bunch of memory for return value, and call previously imported function from WYSI Preview 1. Yeah, when we get result, we check it if it's 0. If it's 0, everything okay. So we can read from memory result and return it. Otherwise, check will throw exception. So yeah, basically what we do here. Let's compile it and run in WasmEdge. We use 0.14 here. So we provide enable GC, enable exception handling options, and path to our Wasm file. Yeah, it looks like working. Nice. We can change something to make sure it's not fake. It's right, and current time to make sure it's not hard-coded something. Let's compile it again, and okay, works. Nice. So yeah, we'll have good support in IDE for Wasm targets, Kotlin Wasm targets. So we have navigation, completion, everything you can expect from IDE. What else? Yeah, basically that's it about demo. Yeah, WebAssembly and Kotlin are great together, And our ultimate goal is providing the best end-to-end experience for any kind of applications. So I encourage you to check it out. Links, you can find slides with this link. I hope you enjoy this short talk. And if you want to hear more about Kotlin Wasm and to chain around, you can again watch the talk from KotlinConf. If you prefer to read, here is a link to our documentation. Please check out and try examples. Also you can join our friendly community in Kotlin Wang Slack. Join our WebAssembly channel. It is a nice place to chat with other folks, to ask questions, to get help, to get updates. And feel free to catch me in social networks by last name. Don't hesitate to ask me anything about Kotlin or WebAssembly. Basically, that's it. Thank you, everyone. Thank you for your time.
All right, thank you so much. Yeah, that's excellent. I love it. So, we should definitely do more to get some of our more popular applications ported to Kotlin. So, for instance, our AI inference applications, right? Right now we have the Rust API. People complain about that. We may have JavaScript later, but I think Kotlin would be a really nice addition. To run AI inference with our other plugins. So I think now it opens up so many possibilities. So yeah. I love that.
But yeah, I think next step is component model and WYSI things, which will dramatically improve development experience.
Yeah. All right. Yeah. So and we'll leave the question to the end. So so next up, we're gonna have Fernand come back again and to talk about the large language model plugin again. So so one of the like I mentioned earlier, one of the shortcomings of our large language model inference system that's called WasmEdge is that it only runs on Mac and Linux. So it runs on Windows, but it's through the WSL. So it's not really native. Part of the reason is we had a problem with WASI support on Windows in the past. So because that system needs to start API server that would require full socket access on Windows systems. And another thing is once the GPU access and when the plugin was compiled to Windows, there are also some problems. But I'm happy to report all those things are being fixed. So I asked Fernand to come back, talk about that. By the way, I just find out I have a CNCF live cast that I need to go to, so I wouldn't be here to close the questions at the end. So I will ask Hydai to do that. So, but Fernand, please come. Yeah. All right. Thanks.
As you know about that, we can now run the NN model on the Windows now. The command line is like the first you have to get the Wasm file from this URL and the GGUF file from GameFace, and then you can run the command line like this. And I'll try this now on my laptop. So it is running a Llama 3 model and answer the question I have given right now. And if you want to leave, just press Ctrl+C and it will end. Okay. Any question?
Well, let me say something about details. So one thing is that we are in this version 40.0. Actually, you can just download the zip from our website. So let me share my screen and for this information. One. So when you are using the Windows, and previously you have to install the WSL or WSL2 and use the Linux container to run our installer or WasmEdge library in the full Linux environments. But now, if you want to use the Windows version, you can just go to our Redis essays and you can find lots of it and just search for the Windows part and the Windows part here. Okay, so first of this is Just the WasmEdge core itself, and not our today's target. You have to find that if you want to use the CPU only version, you can download this plugin, which is the GGML 14.0 Windows. And if you have installed the CUDA runtime on your Windows platform, you can download this version, and you will just run it and like the previous demo. And so that's why the FNAF set the GPU layer to 100 to enable the CUDA GPU computation. Yeah. So the only thing you need to do is to download this zip file and unzip it and just execute. Most of the steps are just the same as you run the command on the WSL. Yeah, just the execution file is different. In Linux, we only have the WasmEdge, but on the Windows, you have to run it with wasmedge.exe. So that's the only difference between Windows and other platform. And we also know that on Mac OS and Linux, we have the installer, so you can just install the whole dependency smoothly. And we are still working on the PowerShell installer and or the Microsoft installer package. Yeah, we still figuring out how to package our plugin into these two way. And once you're ready, you can have an easy way to install the WasmEdge plus the plugin. Yeah, but for now, you have to download it and unzip it and execution it. Yeah, so there's something I want to, just share. And so that's all of our demonstration. And so I think we can just answer any question if the chat have any question.
May I ask a question in general, not about this part?
Sure.
Yeah, question about the debug capabilities in WasmEdge. Do you have anything around it? Do you have plans around it?
For the debugging capability, actually we have a new proposal which will implement the Wasm code dump. So once the Wasm application encounter the trap, and it will just dump the stack information, the function signature, and lots of information into the Wasm code file. And then you can use the Wasm edit tool or the Wasm GDB to retrieve those debug information. This is the current debugging solution we are working on. And I'm not sure if we still need to implement the Wasm devolve proposal because it's a very old one, and I'm not sure if that proposal is still active or not. Yeah.
How about more classical ways to debug with with LLTP or these more modern things, debug server protocol, and any way to debug your application online, not based on some logs?
I will say currently we don't have such plan due to the engineering capacity. Yeah, but do you have any recommendations such as mechanism that we can investigate and try to integrate?
I don't have specific recommendation which way is better. I can share our current state. Like we inside browser we use source maps, so it just works inside the browsers. But for standalone VMs, I don't expect any support for source maps, and we going to support generating source information with Dwarf. And I saw some VMs support or ongoing support Dwarf and some kind of LLTP GDP protocol to debug. Recently, not recently, but about I know a few months ago, there was posted RFC to Wasm time around debugging capabilities. It's more wide things. I'd recommend to read that. It's interesting ideas. Another thing is there's the more modern, more high-level protocol called debug adapter protocol. It's something similar to language server protocol, but for debugging. So this is topics around what we're looking and from our side, from Kotlin side, next things what we're going to work in terms of debugging is generating dwarf and trying to integrate with VM supporting dwarf.
That's great. Yeah, and that's the thing we are, we always want to do that. But yeah, we will try to find some resource and choose a way to implement it. Because previously our focus is use the code dump first, and I believe that's our our second stage to implement the, let's say, for the GPT protocol or something like that. And yeah, but I will add in to our roadmap and to make sure that we will always check that there is a milestone and we have to do that in the future. Yeah, thank you.
Cool. Another question, not about debugging. You may have seen when I run an application inside WasmEdge, it prints warning. Is there a way to suppress this warning to turn off with some key? I think it's printed to a standard output, so you even can't filter out it by.
Oh yeah, that's a good question. Let me create an issue then, and we will have option. Actually, we'll let user to change the login label, and yeah, I believe that's one thing we forget to do that, because currently you cannot change anything of it from the CLI. But in the SDK, we only provide that the standard option and the other is the debug option. We only provide two options, but we can extend it into multiple labels, so developer or users can change the login process by the
working levels is probably a good way to control it. Another idea I had in mind was probably such warning, such logging things, internal VM logging things should be printed to error stream. I think it's a bit more logical. So you can, if I don't want to see these messages on my screen, I can redirect this error stream to file or dev now.
Yeah, sure. We can do that.
Cool. That's it from me so far.
That's great. And if we don't have any other question, let's finish it here. And thank you for coming here to share the Wasm GC for the community, and have a nice day. Yeah.
Thank you. Have a good day.
Yeah. So
see you
next month. Bye bye.
Bye.